three people who have spent about 3 decades thinking about exotic materials. And so if you think about materials, like you get a little block of ice and you can just put it in a room and it'll just sit there as a block of ice. And then you'll heat it up and it'll turn into a liquid and flow over the floor, but it won't go into the air. And then you'll heat it up a bit more and then it'll suddenly release itself from its fellows, the individual molecules of water, and go flying around the room as this invisible gas called steam. And you can heat up a bit more and it'll turn into a plasma where the electrons get ripped up. But if you take it the other way, down into low temperatures, you can start running into weird phenomena, quantum stuff. So
this is all at a molecular level that we're talking about.
Molecular and atomic.
Right.
So normally you don't see quantum stuff easily. You've got to go looking for it really hard. Einstein had troubles with it, and that was his big mistake. And so when you get a layer of atoms, one atom thick, just one atom, not trillions, just one. And in this strange flat land and in low temperatures, or both, you start to run into the field of exotic materials. And for this, they won the Nobel Prize. And so with these exotic...
So, sorry, why is it exotic?
Well, you know how if you sort of put your hand in some water and start stirring it, it'll stop after a while?
Yeah.
Well, you can get some liquid helium and you can start stirring it. Mate, you can go away until the end of the universe and it'll still be rolling.
That, like perpetual motion?
No, you don't get anything extra, but it doesn't. It's got zero resistance. Okay, I won't use the phrase perpetual motion, but it's got zero resistance. But with quantum land, you can drop the resistance down to zero, not just really small, zero, and you put an electrical current into it, and it'll run forever. And you're thinking, well, what use is this? The MRI scanner. You have an MRI scan of your brain, you've got this enormous magnetic fields, and the amount of current you're putting into the wire would melt the wires, except they're superconducting with liquid helium. And so every day we're benefiting from these people's research.
Well, let's stick with that theme of things tiny,
yeah,
very small, microscopic, and the chemistry prize awarded to those who are exploring nanotechnology, specifically the world's tiniest machines, I guess.
The tiniest machines. So you and I, we've dealt in the past about how on bacteria and the cells in your body, the cilia, which we used to think would wave, actually spin around like a little electric motor. These people are making the electric motors.
It also gives rise to this technology where you can have infrastructure that repairs itself. For instance, a bridge.
Yeah.
Where it may have a crack in its concrete.
That's right.
And would automatically repair itself.
You can have the smart stuff happening at an atomic level. Mind you, there are some people, such as Prince Charles, who will put up a warning note saying, look out for the grey goo, where we make these tiny machines and they decide they'll turn everything into something else. And we can't see them. Right. They just go and turn the entire planet.
The rise of the machines, albeit very small machines, but they could still take over the Earth.
Oh, given enough time. And they can reproduce themselves. But on one hand, think of you make up a mini chainsaw that goes in to find a cancer and then just chew it up, and then a little chewing machine that eats it up and then breaks it down.
All right, we should also talk about the prize for medicine.
Ah, and they discovered stuff that eats stuff up and then breaks it down. So you've got roughly 37 trillion cells in your body. And in the early 1960s, they discovered that there was a little compartment inside called a lysosome where things would get broken down, things being chemicals, and they thought it was just like a wholesale junk device. Since then, they've discovered it's far more complex. The things included that would break down would be other little substructures inside the cell, and viruses, and bacteria, and proteins. Okay, you need about 400 grams of protein a day. You eat only about 70. It's always been a big mystery how you survive. These things make and recycle the proteins. These structures are not just garbage units, they're essential for a single fertilised egg to turn into a complete baby, embryogenesis. There was one guy, a Japanese guy, and he started studying yeast, and he discovered this world inside yeast, and he just burrowed away by himself for about 25 years, and so he got the Nobel Prize for discovering that these little garbage dumps are actually essential for the running of our cells, and this could have betterment for humankind further down the line.
Karl, if I look at the winners, those who have been awarded the Nobel Prize in Science this year, as with many years, most scientists seem to be men. And this was raised again this year with physics, for instance. A woman has not won the prize in physics for 53 years.
Yes.
Is that a problem?
Yes, but it shows that we have a society where we are wasting the brain power of half of the population, and this is a wake-up call that we should do something about it. And now we should head down a pathway to open that up. But you're right, 53 years.
But you think it starts at school then?
It starts in our whole society. Women, in many cases, are treated as second-class citizens, and then if you're poor, if you belong to the wrong religion, have the wrong skin colour, the wrong type of hair, whatever, there are many reasons for sending people to the back of the queue, and that's just a waste of brain power if you look at it from a straight, let's use our society properly, and that completely ignores the social justice side of it as well.
Dr. Karl, thanks.
Thank you, Dr. Andrew.